All right, let's take a look. Lesson 6. Let's start with the example. These are called fractional equations. So we're actually solving for x. It's kind of like basic algebra, but it's not quite so basic. We're on page 49. We're going to start at 49 and example 6.1. So here we go. We've got fractional equations. So what do you think we're going to have? We're going to have fractions, right? So x plus 2. This is example 6.1. I'll put right here so you'll remember. And equals 5 over 3. All right, here we go. We're trying to solve for x, correct? Yes? Do I have a amen? I'll even make it another color. Well, I thought I was making it. Let's try this. All right, there we go. There's the x right there. Everybody see it? And that's what I'm trying to solve for. That's what I want to get by itself. Well, there's a little trick to this. And I'm going to do this in another color. We'll try this nice blue right here. Okay. What we're going to do is it's a lot easier to solve for x without the fractions. Would you agree with that? Yeah, okay, none of us like to really work with the fractions. Now, I harp on this all the time about not using a calculator for fractions and all this kind of stuff, because you really can't do this problem on a calculator anyway, right? So even, I mean, you guys haven't had me as a teacher before, well, except you had me a little bit. But anyway, we're doing this without a calculator. You can't use a calculator with this stuff anyway. Maybe on some stuff, but what we're going to do, you got to understand how fractions work. What we want to do is we want to get rid of the denominators. If I don't have any denominators, then guess what I don't have? If I don't have a denominator, then I don't have a what? A fraction, right? I don't have a fraction. All right, so we want to work with it so we don't have denominators. Watch what we're going to do. We're going to actually get rid of all these denominators. And one way to get rid of the denominators is to multiply everything by a common denominator. So look what we have. We got 7, we got x plus 2, and we have 3. What in the world would be a common denominator with all three of those denominators? What if you had this? Let's go back in time a little bit, all right? Let's go 2/3 plus 5/7. If I wanted to find a common denominator, what do I do to find a common denominator? Come on, guys. Just say it. The number they both go into. Okay, so what number do they both go into? Okay, what did you do with those two numbers? Okay, that's all I'm asking, all right? I'm not asking rocket science questions here, okay? I'm not trying to trick you up. I'm really not, okay? I'm just trying to get to see if you're paying attention. So if I have a denominator of 3 and 7, what do I do to those two numbers to get a common denominator? I multiply them together, okay? So now watch. I've got a 7, I got a 3, and I got an x plus 2. All right, so I got an extra denominator in there. But what do you think I'm going to do to find a common denominator? Multiply them together, right? That's why I asked you this question over here. You with me? All right, so I've got all three of these. I want to find a common denominator. And so I just multiply them together. So what would that be? It would be 21 times x plus 2, wouldn't it? Watch what I do. I'm going to multiply everything by 21 times x plus 2. I'm going to multiply this side by that. I'm going to multiply this one, and I'm going to multiply this one by that common denominator. And watch what happens. I'm not going to give you any explanation why I'm doing it or anything. Just watch what happens after I do it. Remember what my goal is. My goal is to get rid of the denominators, isn't it? It's not really to add the fractions together. That's not what I'm doing here. I'm trying to get rid of the denominators by multiplying by something, so the 7 will cancel, the x plus 2 will cancel, and the 3 will cancel. That's what I'm trying to do. So what do we say we're multiplying by? 21 times what? X plus 2. I have to multiply all three of these terms by the same thing. 21 x plus 2. Sorry, I should have given myself some more room on this. 21 x plus 2. But if you write this down, follow it along, you can write a little bit neater than what I just did. Now watch what we just did. The whole reason that I did that, all right, and I'm going to make this red. The whole reason I did that is so the denominators cancel out. Remember what I want to do. I want to get rid of the denominators. I don't want the denominators there, so I want them to cancel out. So look what happens. If I multiply by that common denominator, what happens to the 7? The 7 cancels out. So 7 goes into 21 how many times? 3 times. All right, we'll mess with that in just a second. All All right, let's cancel out all the other denominators. Look at this. This is an x plus 2, isn't it? Well, that x plus 2 cancels with this x plus 2. See it? And look what happens here. What do you think? That 3 cancels with the 3 here, so what am I left with? A 7. All right? Now let's clean it up. It's pretty messy right now. So let's clean this thing up. What do I have on top here? I got a 3, I got an x plus 2, and I got a 4, and they're all being multiplied together, right, with that term. So let's write it real nice. So 3 times 4 is 12, and then I'm just going to write it x plus 2. I'm not going to do too much in my head in this step. I'm just going to multiply this stuff on the top. That parentheses, I'm just going to keep it in parentheses. Plus, now what do we have here? What canceled out? The x plus 2 canceled, but I still have a what? A 21 and a 3. So what do I do with those two? Multiply those together. So what is that? 63. Alright, let's do this. Look, the 3 canceled out. It went into this 7 times. So what am I doing with all 3 of these things? Multiplying them together. Let's do the easy ones. 5 times 7 is 35. And then times x plus 2. Alright? Now this looks a lot better, doesn't it? This looks a whole lot better. Why does this look better to solve for x than what we started with? Because we don't have any what? We don't have any denominators. It's not a fraction, right? We have no fractions anymore. Okay, now it's just basic algebra 1 kind of stuff. All right, so let's just do this really quick. I'm not going to spend a lot of time explaining this. Distribute the 12. So I've got 12x plus 24 plus 63 equals, distribute the 35. So it's 35x plus 35 times 2, which is 70. Let's do this. I see these two right here. I can add those two like terms up. Let's do that first before we do anything else. So would that be 87? That's 35x plus 70. Let's get the x on the same side. So you could put the 35x on the left-hand side, or you could put the 12x on the right-hand side. Right? I'm going to put the 12x on the right-hand side, just to make it positive. Is that all right? So I'm going to subtract a 12x from both sides. Now look, this 70 is over here with this x. I want to move that, so I subtract a 70 from both sides. Look what I get. 12x is canceled out. 87 minus 70 is what? 17. And then 35 minus 12 is, what's that? 23. And that added up to 0 or canceled out. And now, one more step. Divide by 23. And there's your answer. X equals, make that equal sign look a little nicer. X equals 17 over 23. Mark your phone. Here's all the steps I was going through right here. Okay. All right, and then there it is. 17 over 23 is your answer. Simple. So the thing that's kind of new to you probably is getting rid of those denominators. Now look, I didn't add any fractions together, did I? What I did though is I found what was in common. Right? They call it a least common multiple if you want to be real technical on it. Found the least common multiple, or the common denominator, right? You're probably more familiar with that. And then I multiplied everything by that common denominator. Why did I do that? Because I wanted to multiply this fraction by something that has a 7 in it, and 21 had a 7 in it, didn't it? All right, so I multiplied everything here. Now remember, what I do to one side, I got to do to the other side. So I have to do that to everything. So look, the x plus 2 canceled, the 3 canceled here. I multiplied this stuff left, and then I got this nice pretty equation right here, and then the rest is just cake. The rest is easy after I get to this. All right, it's changing it from the fraction into these whole numbers is the key to this. All right. Go back on YouTube and look at it if you didn't quite get it today. All right, that's the beauty of this. All right, let's do example 6-2. So, what did I just do? I changed the fill color to white. No wonder I can't see. All right, actually, I don't want the fill to white. I want the fill to nothing, and I want the stroke to black. How did I change that? I don't know. Anyway, here we go. This is example 6-2. This is on the top of 50. Good, Mark, you're there. Okay, let's write this out. This looks a little ugly at first, but what we're going to do is basically what we did in that last example, but they add a little bit of extra stuff here. Now look, they have an x and a y, don't they? So if I'm going to be able to solve for both x and y, I need more than just this one equation. I need a second equation. And guess what they give you? A second equation. How about that? That was nice of them, wasn't it? Alright, there it is. I'm not going to even start trying to solve for x just yet. What I want to do is I want to take both of these equations. This looks like one of those substitution elimination equations, doesn't it? And you'll notice they'll put this little brace in front of it, and that means you're going to do either substitution or elimination. But I'm not going to mess with it just yet. First thing I'm going to do is I'm going to change it so I don't have any decimals and I don't have any fractions. All right, just like we did before. Look at this. Let's change this so I don't have any fractions. I got a 7 and a 5 on the bottom. So what do? I got to multiply by the what? What did we do last example? What did we multiply by? The what? Give me the word. Say it. What? The denominators? What about the denominators? Give me a word before that. Come on, we said it like half dozen times. We multiply by a, what's that? Common denominator. Is this ringing a bell to you at all? Okay. All right, come on, stay with me here, all right? So we multiply by a common denominator. So look, common denominator would be 35, wouldn't it? Because this 11, what's the 11? 11's over 1, isn't it? So the common denominator between 7, 5, and 1 would be 35. So we multiply everything by a 35. So let's do that and see what we get. Actually, I'll keep this red. Look what happens. I'm not going to go 35 times 3. Don't do that. The whole reason I multiplied by 35 is so the 7 would cancel out. The whole reason I multiplied this by 35 is so the 5 would cancel out. That was my reasoning. Make sense? So watch what happens. This 7 cancels with this. It goes into it how many times? 5 times. This 5 goes into this 35. How many? 7. Now, nothing goes into this, right? Because it's just straight up multiplication. All right? So now what we can do is we can clean it up a little bit. What's this x term going to be? It's 5 times 3. So it's 15x. So let's write it over here nice and neat. There's 15x. Plus, what about this right here? What's that going to be? How about 14? 7 times 2. Okay? 14y. And then 35 times 11. That would be what? 385? Do you know how to multiply by 11? Two-digit numbers? Watch. You take the 3 and the 5, you separate it, you add the digits. What do you add up to? 8. That's how you multiply by 11. Isn't that cool? Alright. So that's that. Look at this one down here. Now this isn't a fraction, but it's decimals. This is actually a little easier. I don't know if you learned this before, but watch. Remember, whatever you do to one side, you can do to the other side. Which one of these decimals do I have to move the most number of places in order to make it a whole number? Hear what I just said? Which one do I have to move the most number of places in order to make it a whole number? The first one, okay? How many places do I have to make it to get it to be a whole number? 3. 1, 2, 3 places, right? So if I move that 3 places, guess what I'm going to do with all of these? I'm going to move everything else 3 places. Technically, I'm multiplying by 1,000. When I move a decimal to the right 3 places, I'm multiplying it by 1,000. I can do that as long as I do it to everything. All right? That's a basic rule of algebra, isn't it? Whatever you do to one side, you do to the other side. So I'm going to change that. I'm going to move this 3 places. 1, 2, 3. Okay, and then 1, 2, 3. And let's figure out what they're going to be. So if I move this 3 places, what does that turn into? It's just 3x minus. What if I move this 3 places? Move it once, it goes here. Then I move it 2 more, so I got to add a couple zeros on there. So that gives me 200y. Everybody with me? Now move this 3 places. 1, 2, 3. That means I got to stick a 0 in there, right, to get that 3rd place. So that gives me, it's a negative, what? 370. Did you see that? I move this 3 places, move this 3 places, move this 3 places, and this is what I get. Now, if you look at this, this should look like something that you've been able to do before. And we've done this before. Remember that problem we did with the money, with the pennies, the nickels, the quarters, and all that kind of stuff? Okay, this is basically the same idea. I'm running out of time, so let's go really quick here. So watch. Multiply everything by a -5 right here. I think that might be the easiest thing to do. So when I multiply everything by a -5, I didn't mess with the top at all. I don't think I'm going to have enough time to finish this up. Alright, I'll stop right here and then we'll finish it on the next video.